lecture, and today I see almost 1/4 of what number we had in the first lecture. Okay, so any doubts you have or any problems you would like to discuss from the homework problems? So I have very carefully chosen these problems so that all the concepts which are involved, they become clear to you. Yes, any questions you have? Exponential theta sigma naught. Okay. And you have a sample, right? Single observation or sample? N. Okay. So that is, let me see which problem number is this. This is one of these over here. Huh? 1 part 5, right? So this is same as your uniform 0 theta problem, right? So you have x1, x2, xn, IID with PDF f theta x which is 1 by sigma naught e to power minus x minus theta by sigma naught. X is greater than theta, right? This is the problem you're talking about, right? And sigma naught is a known quantity given to you. You have to test h naught, theta is equal to theta naught, against theta is equal to theta 1. That is the problem you're talking about? Okay. So note that the first thing you should note is I did one small note where I said that it is enough to consider test procedures based on minimal sufficient statistic, right? Because you can, given any test function phi, you can have another test function expected value of phi given t, which has the same power function. So it is enough to consider test functions which are functions of minimal sufficient statistic. Because if there is a MP alpha test, then there would be a MP alpha test based on a sufficient statistic, minimal sufficient statistic. T is equal to xn is minimal sufficient. So T has PDF. Let me call this as G theta T. Sorry, x1, right? Minimum is. Now you know that in the case of exponential, minimum is again exponential, right? You can just find it out. It's straightforward to find it out. Which is n by sigma naught, e to power minus n by sigma naught, t minus theta. Right? Minimum, this you know, right? This is minimum. We have used it many times, right? So I try to find out what does the Neyman-Pearson lemma say. So let us look at what is my delta t, which is f theta 1 t minus c times f theta naught t. Is that okay? Same thing I do. Now here I am not considering. You see, I have said that when supports are not same, it's always safe to take this thing. You can take ratio, it would be one thing, but then there's a possibility of you making an error. So, and what I've said, since this you're doing it for the first time, I would say I would suggest that if support is not same, then consider the exact thing. No, that would occur. That would occur. Even ratio, if you consider, it would come. I'll come to that later on. But first, let us do this way. Okay. So what does that mean? Now here, different cases would come because t is bigger than theta. So range could be theta naught to infinity or theta 1 to infinity. So you have to consider two cases separately, where theta 1 is bigger than theta naught and theta 1 less than theta naught. So let us consider both cases simultaneously. Case 1, theta 1 is bigger than theta naught. Case 2, theta 1 is less than theta naught. Okay, now let me ask you, can you use your intuition to tell whether you reject for large values of t or values of t? Yeah? Yeah? So what he's saying is, if in this situation, you reject for large values of t, why? Your answer is correct, but why? Yeah? Location parameters, so? Why? So you'll have to show stochastic increasing, right? That. So his answer is also correct. In fact, you can show that all location families have a stochastic increasing property. Just try to show that. So here without it, otherwise also you can use common sense when you find out what is expected value of t. Expected value of t would be nothing but theta plus sigma naught by n. So on an average, t gets theta naught. So if theta naught is large, on an average you will get t large, right? That is also an intuition-based argument, right? So okay, but that has nothing to do with the discussion I'm going to have now. But I thought it's always good to use your statistical thinking to find out what would be a reasonable critical region. Okay, so let's look at this situation. Then in this situation, what happens is your theta naught is over here and theta 1 is over here. What is my support? Support under alternative hypothesis is from theta 1 to infinity, and under H naught it is from theta naught to infinity. So my support is theta 0 to infinity, right? So my delta t, there would be one situation where t is between theta naught to theta 1. What would be in this case? In this case, f theta 1 is 0, right? In this case, f theta 1 is 0. So it is only minus c times f theta 0 x, which is 1 by sigma naught, n by sigma naught, e to power minus n by sigma naught, t minus theta naught. Is that okay? Okay. Now let's look at another situation when t is bigger than theta 1. What happens in this situation? When t is bigger than theta 1, then both are coming. Both PDFs are coming. Since this is f theta 1 minus c f theta naught t, I take out the common portion outside. So common portion would be everything except where theta is involved. So that means n sigma naught would be common. E to power minus n sigma naught t would be common. So this would be n sigma naught e to power minus n sigma naught t. Then under theta 1, it would be e to power n theta 1 by sigma naught, right? E to power n theta 1 by sigma naught minus c times e to power n theta naught by sigma naught. Would it be all right if I just do one case and the second case arguments would be exactly same, right? If you have difficulties, you can always discuss it, but arguments would be exactly same. In this case, for example, delta t, what we want? Theta 1 is over here, theta naught is over here. So when t is between theta 1 to theta naught, then what happens? Your theta naught thing is 0. F theta 1 thing is there. So it is only f theta 1 x, which is nothing but n by sigma naught e to power minus n by theta 1 sorry, e to power minus n by sigma naught t minus theta. Is that okay? Now let's consider the situation where t is bigger than theta naught. Note that I'm not bothering about these boundary points because it is a continuous distribution. So probability of these t is equal to theta naught, t is equal to theta 1, they all would be 0. Now when t is greater than theta naught, both are coming. It will be this kind of a situation, right? So I can write down as it is. So n by sigma naught e to power minus n by sigma naught t e to power n theta 1 by sigma naught minus c times e to power n theta naught by sigma. Is that okay? Now you know that I have to make phi 1 where delta t is positive. I have to make phi 0 when it is 0. And I have to make phi t to be 0 when it is less than 0. Right? And you can choose C as per your convenience. Right? So let us look at what are the possible values. C is greater than or equal to 0. So the first choice possible is C is 0 itself. In that case, this whole would become 0. And then this would be a positive quantity. Right? So case 1A, C is equal to 0. Right? Because C is any quantity greater than or equal to 0. If C is 0, then what does my delta t becomes? Zero. If t is between theta 1 to theta 0. And it is this quantity, which is n by sigma naught e to power n by sigma naught t e to power n theta 1 by sigma naught. What is this quantity? This is some positive quantity, right? This is some positive quantity. So by part 1 of Riemann-Pearson lemma, by part 1, what is the UMP alpha test or most powerful alpha test? Phi star t in this case I don't have a choice, right? This is for t bigger than theta 1. Sorry. This is t between theta naught to theta 1, t bigger than theta. So in this case, because it is positive, I have to take my phi to be 1. There is no choice available to me. Because that is what I said. If delta t is positive, you have to take phi to be 1. Delta t is 0, you take it to be gamma, and so on. Now in this case, I have to make it a gamma because delta t is 0. And how do you choose gamma? Such that expected value under theta naught of phi star is alpha, exactly here. All right. So let me just continue over here. That case I'll consider separately. So what does that mean? That means gamma times probability under theta naught that your xn t is xn. Xn lies between theta naught to theta 1 plus probability that t is greater than theta 1, which is xn is greater than theta 1, Should be same as alpha. What happened? X ordered 1, yes. Is that okay? Now note that under H naught, under theta naught, X1 is always bigger than theta naught. So this probability would be same as 1 minus of this probability. Because why should I calculate two probabilities separately, right? I just want to minimize my work, right? If you want, you can calculate it separately, but I'll not do that, right? So I just want to minimize my. So I can write down this as gamma times 1 minus this probability. So which is same as gamma minus or plus 1 minus gamma, right? This, is that okay? Times probability that x1 is greater than theta 1 is alpha. Is that okay? I've written down because under H naught, x1 is always bigger than theta naught. So this probability would be same as 1 minus this probability. So that would be gamma minus gamma times this probability. So gamma minus gamma times this and this. But you know that what is the distribution of minimum? N times minimum minus theta naught by sigma naught is exponential, right? So this is same as gamma plus 1 minus gamma times, what would be this probability? This would be e to the power minus n by 1 minus theta naught. Is that okay? Because if x is mu sigma, then probability x greater than t is nothing but e to the power minus, and theta 1 is bigger than theta naught. Is that okay? So what do you get as gamma? You can get now gamma, right? So you've got the value of gamma. Is that okay? So basically what you get is gamma times 1 minus e to the power minus n by sigma naught, theta 1 minus theta naught. Just make sure that I'm not making any mistake. Hopefully I'm not making any mistake, but so you get the value of gamma. So gamma is nothing but 1 minus e to the power minus n by sigma naught, theta 1 minus theta naught, inverse alpha. Yeah, I mean, over there? No, this step or this step? Below this? This one? Second last time, okay. That would be 1 minus alpha, right? That is what you know. What are you saying? Let me. This step is okay, right? This is okay, right? So let us look at. Then I'm looking at. I'm taking gamma, all right, and then that becomes e to power minus, right? Alpha, right? Alpha minus. Or I can take this. Yeah, alpha minus e to power minus n by sigma naught, theta 1 minus theta naught. Is that okay? Then gamma is nothing but this inverse into alpha minus e to the power minus n by sigma naught, theta 1 minus theta naught. I hope I have not made any calculation mistakes, so this is okay. What happens in this case? Case 2a, c is equal to 0. So one UMP alpha test I have obtained, right? For this value. Case 2a, if c is 0, then what do you get over here? This is positive and this is positive. So phi star is always 1. So if I want E theta or not phi star to be alpha, and alpha is between 0 to 1, I cannot get anything, right? So this will not work because my alpha is between 0 to 1. And I want my E theta 0 phi star to be alpha. Okay. Okay. Now let us consider case 1b. Case 1b would be when C is strictly greater than 0, but this quantity is positive. That means C is less than e power n theta 1 minus that, right? So case 2 would be case 1b would be C greater than 0, but less than e power n by sigma naught theta 1 minus theta. Is that okay? Is that okay? Now what happens in this situation? C is this one, right? C is positive, so here it is negative. And what happens over here? It is positive. So that means in this range, it has to be 0, and in this range, it has to be 1. So my phi star, so it would be some negative quantity, some positive quantity, if T is greater than theta 1. So what it means is by Neyman Pearson lemma, MTH alpha test is 0. But I don't have any parameter in my hand to control the level. So it will have a fixed level. So this can be MP alpha test when alpha is same as, yeah, probability that T is greater than theta 1, which is equivalent to saying that e power minus n by sigma naught theta 1 minus theta naught is same as alpha. So only for one choice of alpha, this would be MP alpha test, right? Only when alpha is this quantity. Now note that in the last question also you have to make sure that for what ranges you can attain that alpha, right? That alpha may not be attained for all ranges. So you'll have to be just a little bit careful. I solved over here, na? So suddenly this alpha has to be less than 0 because gamma has to be greater than or equal to 0. This is positive, so this quantity has to be positive. So that means this will be attained only when alpha is less than or equal to less than e to power minus n theta 1 minus theta naught. For other range, you get it from here. Is that okay? Are you getting what I am saying? Yeah, because alpha would be anyway a fixed value given to you, no? Yeah, alpha would be given to you in the beginning, for example, 0.05. It may. Yeah, so if your alpha is, for example, if alpha was less than this quantity, you don't have a test in this situation. So in this situation, you'll get a
Sir, sir, we can't hear you.
Case 1C would be C exactly same as that quantity. What happens over here? C is positive, so this is some negative quantity, and this would be 0. Is that okay? This quantity is going to be 0. So by Neyman-Pearson lemma, what would be your test? It just gets interchanged, right? So it would be 0 if t is between this, and this would be gamma if this happens. Is that okay? And how this gamma has to be chosen? That means gamma times probability t greater than theta 1 should be same as alpha. What does that mean? It means gamma times e to power minus n by sigma naught t minus theta naught is equal to alpha. What does that mean? That means gamma would be same as e to power n by sigma naught t minus theta naught into alpha. Right? Now note that this quantity has to be between 0 to 1. Sorry, not t. Theta 1 minus theta naught. This quantity is clearly bigger than 0, but this quantity should be less than 1 also, right? Gamma has to be less than 1. So this would be less than or equal to e to power minus n by sigma naught theta 1 minus theta naught. Right? So note that different ranges you get a different test, right? Okay, depending on what your level of significance is. So this would be a level of significance. So this test would be the MP alpha test. If your alpha is less than or equal to e to power minus n sigma naught theta 1 minus theta naught. This would be a test when alpha is bigger than or equal to this, and alpha is exactly that, you get a different test. Now the third situation would be case 1D when C is bigger than this quantity. C is bigger than this quantity. What does that mean? This is negative. This is negative, so phi star is 0. So expect to phi star would be 0, which cannot be alpha, right? So there is no test in that situation. So you see, slightly tricky in the sense that depending on where alpha is, your test changes. Now, normally this would be a situation which would be, now note that your intuition might fail, right? Here, for larger values, you are rejecting only with probability gamma. You're not rejecting with probability, full probability 1, right? Is that clear? Anything one has to ask? Somebody has to ask? Any confusion still if you have? Now the question is, are these tests unique? Let us look at this situation. In this case, I have a liberty to play around with gamma. So rather than considering that gamma in the region, this was in the region where? Between theta naught to theta 1. Right? What I can do is, this gamma, I shift some of it to the 0 and some of it to the 1. And I bring a point C in between. So I say that this is 1 if x1 is greater than C, and 0 if x1 is less than C. I can consider that test. I want label to be alpha. First of all, that test would be, if that test has the same power as this test, I'm done. We can consider power of this test. And then choose C such that that has that same power as that test. And then so that that also has a label alpha. So it will be a two-step. First, you find C. And so that, you want me to do that? To show the non-uniqueness part? So you see, what do you get as a test? Let me do the case, this theta 1 bigger than theta naught. So what is your test, 5 star? Would be 1 if x1 is bigger than theta 1, and gamma, which is basically 1 minus e to power minus n by sigma naught, theta 1 minus theta naught, whole inverse alpha minus e to power minus n by sigma. Is that okay? This is for the situation where alpha is bigger than e to power minus n by sigma naught, theta 1 minus theta naught. Is that okay? You see, normally your alpha would be small. So this will not be a situation normally, right? 0.01, 0.02. So normally, if theta 1 and theta naught are slightly apart, this quantity would be, in fact, if sample size is large, then this quantity would always hold, because e to power minus, this goes to 0, right? As n goes to large, n becomes large. Okay, so yeah, if x1 is theta naught to theta 1, right? Is that okay? So I know my Neyman Pearson lemma. If there is another UMP alpha test, it can change only in this situation. My intuition demands that, or my intuition suggests that any test which rejects for larger value of x1 should be all right. So this suggests that over here, even this range I can break it. And I write down a new test 5 star C 1 if x1 is between theta naught to C and 0 over here, and lower part I can make it only x1 greater than C. This looks like a reasonable test, but this doesn't prove that it is UMP alpha test. This idea I have got only from the uniqueness of MP alpha test, that I can change my uniformly most powerful test over here. If I can change over here, one way to change it over is, rather than considering gamma, I break this reason. In some reason I can consider it as 1, and in some reason I can consider it as 0. And that is what exactly I am doing. But to prove that this is most powerful alpha test, I have to show that the power of this test is exactly same as this. That means I should choose C such that power is exactly that. So let's look at what is the probability power of this test. So E theta 1 5 star C is how much? Probability under theta 1 that x1 is greater than C. What would be that quantity? Your C is between this quantity, because that is where you have chosen. So C is less than theta 1. What will be this quantity? It would be 1. What is the power of this test? No, this is coming out to be more than 1. There is some issue. Yeah, it is 1. This is also 1, right? This is also 1, right? So whatever C you take, as long as C is bigger, less than theta 1, your power is 1, so this is also uniformly most powerful test. What about that? So that means I have now freedom to choose C. And I have a lot of freedom. That expected value under theta naught should be less than or equal to alpha. So whatever C you take, as long as C is less than theta 1, and that I have to take C to be less than theta 1. So I choose now E theta 0, phi star C should be less than or equal to alpha. That is what I want. So what does that mean? That means probability under theta naught that x1 is greater than C should be less than or equal to alpha. What does that mean? E to power C is between theta naught and theta 1. Right? And x1 is under h naught theta. So this would be equal to e to power minus n by sigma naught C minus theta naught should be less than or equal to alpha. Is that okay? So many choices of C. So you have infinitely many MP alpha tests in this situation. Which one would you prefer? Which one would you prefer here? There are infinitely many MP alpha tests. Each of them has a power 1. So which one would you prefer? For which the type 1 error is minimum. So that means this quantity should be 0. This would be 0 when? When C is infinity, right? So the best test is again turns out to be phi star C is 0 when x1 is bigger than theta naught. Right? Now you can consider the second case would be more interesting. So this is like that uniform case which I considered, right? Uniform theta theta 1. You have to test that x is uniform 0 1 against x is between 1 to 2, uniform 1 2. Now the second case where this quantity is less than or equal to 1, so that means alpha is less than or equal to e to power minus n by sigma naught theta 1 minus theta naught. That is more interesting case. Is that okay? What happens in this case? So you get infinitely many So what would be the second situation? What would be the second situation when this quantity is less than or equal to 1? That means alpha, if your level of significance is less than or equal to e to power minus n by sigma naught, so your level of significance is less than or equal to e to power minus n by sigma naught. In fact, strictly less than e to power minus n by sigma naught. Theta 1 minus theta naught. What is a phi star over in this case? Is 0 if t is between theta naught to theta 1 and gamma if t is bigger than gamma. I know what exactly this is, e to power n by sigma naught theta 1 minus theta naught if t is what I have done, alpha, right? If t is bigger than theta. Is that okay? Now, first of all, let me ask, is this a uniformly most powerful test for testing theta is equal to theta naught against theta greater than theta naught? is it uniformly most? I've shown that it is most powerful for testing theta is equal to theta naught against theta is equal to theta 1 if theta 1 is bigger than theta naught. My question is, can I claim that this test would be uniformly most powerful for testing theta is equal to theta naught? Why? So because this test depends on the choice of theta 1, the choice of alternative which I have chosen, right? So this test I cannot argue that this would be uniformly most powerful for testing because it depends on which theta 1 you have taken, then it is uniformly most powerful. The result which I did yesterday is that if it does not depend on what point you have chosen in the alternative, then I can say so. So see, this certainly will not be. Okay, so now let's try to find out some other tests. So certainly the reason why this reason I cannot do anything, because where phi star t is 1 or 0, I cannot do anything. So only in this reason I can do it. So that means what I do is I break this reason theta 1 to infinity in two parts, c to infinity and theta 1 to c. In theta 1 to c, I keep it as 0 only, and c to infinity, I make it 1. So that means this suggests that I consider this test 0 if t is less than c, and 1 if t is greater than c, where c is bigger than theta 1. Is that okay? What is the power of this test? First of all, this c has to be chosen such that. So first I try to choose c so that the power of this test is same as the power of the earlier test. What is the power of phi star? So this suggests that there is a possibility that this looks like a good contender for MP alpha test. But I have to play around with C so that I can make it power to be same as the power of this test and label to be less than or equal to alpha. Is that okay? Let us look at what is the power of phi star. Which is same as probability alpha e to power n by sigma naught theta 1 minus theta naught alpha times probability under T1 T is bigger than theta 1. Is that okay? This is same as e to power n by sigma naught theta 1 minus theta naught. And what is that quantity? E to power minus, no, t under h naught. Yeah, so it is exactly this, right? It is exactly this. Because t bigger than theta 1, this would be alpha also over here, right? So power is exactly this. Right? What is the power of phi c star? Which is same as probability under T1 theta 1 that t is bigger than c. T is bigger than c means t is same as x1. And c was bigger than theta 1. So this will not be, so this would be same as e to power minus n by sigma naught c minus theta 1, right? Is that okay? E to power minus n by sigma naught c minus theta 1. C I have chosen to be bigger than theta 1. Now if I can choose c such that this is exactly same as this, then the power of this test is exactly same as the power of this test. So let us try to choose this. This is same as e to power n by sigma naught theta 1 minus theta naught times alpha. So what is the choice of c you get? you get some choice of C, right? You can get a C so that, right, you can solve this and you can get a C. In fact, e power n by sigma naught theta 1 gets cancelled. This gets cancelled. And then you get, you can solve it with this. Now note that here this C does not depend on theta 1. Here this C does not depend on theta 1. So whatever test now you are getting, that would also be uniformly most powerful for testing theta is equal to theta naught against theta bigger than theta naught. Is that okay? Because C is not depending on theta 1. But still, you see, I have not solved it. It only says this power is exactly same as this. Its level should also be less than or equal to alpha. So that means E theta naught phi star C would be nothing but e to power n by sigma naught theta 1 minus theta naught alpha. Then probability under H naught, T is bigger than C. What is T bigger than C? E to power minus n by sigma naught. In fact, it's this quantity, right? Alpha e to power minus n by sigma naught C minus theta naught. And what happened? Which quantity should not be this? This should not be this. This one. This one. Under the E theta naught phi star C, right? No, I have to find. Yeah, E theta naught phi star C is probability that T greater than, yeah, so there is, yeah, sorry. Probability T greater than C. Probability T greater than C is nothing but e power minus n by sigma naught C minus theta naught. And what is this quantity? You can see from here. C is given by this equation. So what is this quantity? Actually, from here, if you solve it, this gives e to power minus n by sigma naught C minus theta naught is equal to alpha. Right? So what is this quantity? Exactly alpha, right? This is same as alpha. So its level is alpha. So this is the most powerful test of size alpha. One good thing with this test is, you see, if you use Neyman-Pearson lemma part 1, it doesn't give you a uniformly most powerful for testing theta equal to theta naught against theta bigger than theta naught. It is only the second part when you do it and try to find out other MP alpha tests, you find that I can get a test of this size where this C does not depend on the choice of theta 1 I have taken, as long as theta 1 is bigger than theta naught. That is the only thing I have chosen. So you get a UMP alpha test. So slightly tricky. So what I would say is you can get a lot of practice if you consider different examples where support is not same. Try to ask all kind of questions which you can ask to yourself. That will make your fundamentals much more clearer, right? Because they give you a clear picture of what is happening inside the. Another example is take the sample from uniform theta 1 theta plus 1. That is one of the problems I have given, right? That is another example which will be very thought-provoking. So try to do that example also. If you have any difficulties, we can discuss it in either lecture, one of the lectures, or even yeah. Which overlapping? So do you have 1 minute? I'll just take 1 minute and then, you see, one part I had done already, a particular case where you have theta is equal to 0 against theta is equal to 1. In that case, the two intervals becomes separate, right? Disjoint. So here again, the situation would arrive whether the difference between theta 1 and theta naught is less than 1 or bigger than 1, right? So you'll have to consider two cases separately, right? One case would be obvious kind of a situation where similar to the one which we considered. If the difference between theta 1 and theta naught is bigger than 1, then those intervals would be far away, and then the interesting case would be where there is overlapping. So I would suggest that try to do that. If you have difficulty, we can discuss it in one of the, but whatever problems I have given in terms of PDFs which have support depending on theta, you can learn a lot from those, right? So I would suggest that you try to do those and try to understand those problems.